Okay, so today's video is going to be about quantum mechanics. In quantum mechanics, our main topic will be superposition. Wait, I think the words are clear. Superposition. Okay, in superposition, first of all, our main what we will main what will be our main focus is definition. Let's not go for the topics. We'll just go and discover whatever we have. But first of all, what is superposition? Superposition is the existing, because for everyone definitions are different. But if the concept matches, it's not, that's fine. Existing of here I will say particles. Is this since it's superposition and also quantum mechanics, we'll go for particles. Existing of particles, not particles, it's particle, existing of particle in more than one state simultaneously. This is what changes the whole concept. Superposition, the key point here is simultaneously existing in more than one state, a single particle existing in more than one state simultaneously. That means, let's suppose we have a qubit. Wait, let me do one thing. Let's suppose we have a qubit. Okay, what this qubit is, let's suppose this is a qubit. And this qubit has 1 and 0. So if it's here and here, either one, it's not in superposition if it's either one. But if it's, wait, let me just, if it's in both, let's suppose it's here, or wherever we want, that is superposition. So superposition means what else could, okay, let's suppose you throw a dart. That's the worst dart I have ever made. You throw a dart and there is a bullseye. What do you call this? Hitting board. Okay, on this hitting board, when not observed, remember, superposition is always when not observed, this thing will exist in multiple states. There will be every single scenario of dart hitting here, and so on. So what we have here is that when not observed, always the key concept when not observed means superposition only exists when you are not observing that what do you call that situation, whatever is happening there. It's same thing is in let's suppose for wave function. What is a wave function? wave function like this, right? It's a wave. Okay, so what this wave shows that the each height gives probability of particle being there, right? So how do we get the exact, not exact, the highest probability when we use this, when we observe it, the wave function will break and we'll get 1 point. If we will have this, so the points, this is the highest point, high, low. So again, superposition, because wave function is, it assumes that the point, if depends on the points, if we are at a higher point, then the probability is high, low means less. So this also is an example of superposition, if I am right. Position. Okay, so then examples of superposition. Quantum computers. In that, the basic example is qubit. So in qubits are of 2, 0, or we could also say 1. These are qubits. Okay, so superposition or mixed superposition, in this we also call it mixed state. Superposition or mixed state. If I write this plus this, what is this? What is this? This is a mixed state. Combine, we can use a gate as well, as we talked in a video. What the gate is actually the one which gives a Hadamard gate. Hadamard gate. Okay, so what is it? Hadamard gate is 1 by H2. This, okay, this combined with this, this whole thing can be written with in terms of psi. Okay, so again, Hadamard gate is a way through which we can make the state a mixed state. Mixed state means superposition. Right now it's both in 0 and 1, and when we take the square of both these, we get equal 1. So if it equals 1, that means we are correct. These two states are in a mixed state in a way that their sum will equal 1. Okay, so this is so what we say is, a qubit is in a mixed state when we are trying to process. Okay, and when we make a measurement, What we get? We get either one of the states. Okay. Then there's one more concept which is known as quantum encryption. Okay. In quantum encryption, we talk about, let's suppose we have two people, Alice and let's get simple, Jack and Bob. Okay. So let's suppose Jack sends a message, okay, to Bob. Okay, but the message is quantum encrypted. Okay, in two ways. One is there are two ways to send it. Either as this is called basis. Okay, one is 1 or 0, and the second one is diagonal. It is either positive, which is 45°, or negative, which is negative 45°. Okay, these are types of qubits. These are encrypted codes. Okay, which is sent over here. So when Bob receives, okay, it will be the communication is done using quantum channel. Okay, so after it's received, Bob will send a message to Alice through normal communication, normal channel. Okay, and ask for only which base he used, either this base or the diagonal base. Ask for only the type of base. Okay, basic. Then what we see is that how it will tell how encryption is stopped. Encryption is secured. Let's suppose if there is a third person. Okay, let's suppose there is a third person. Okay, so if he receives the message and then again goes back, what Bob, Alice, when Bob will send message to Alice, and Alice gives the information, gives info. Okay, and then Bob matches and discards the incorrect. That's how it will work. Okay, incorrect. If there is any error, then he will suddenly know that someone interception happened. Intercept is done. Okay, and so they will know. And again, the same thing about measurement. When Bob will receive, he'll send message to Jack. Here, Alice. Wait, sorry, I'll change back again. Okay, fine. Jack was busy, so he went somewhere else. So he gave the phone to Alice. So Alice, when Bob will send the message to Jack, and they what Bob will do, he will do measurement. Okay, he will do measurement. He will cross check, cross cross check, and he will discard the waste and only look for the correct qubits bits. Okay, and that's how the encryption will work. It's called QKD. I think that was some quantum key encryption, something like that. Distribution, quantum key distribution, and it's one of the secured way that if this person is intercepting, the answer will not match at all. Okay, so superposition. So when he sends the message to Bob, when not measured, the qubits are in 1/2. I'm just giving an example. Plus okay, yeah, that's it. Thank